So here is the all-new video on ratio. So you were taught ratio quite thoroughly in year 9 and hopefully you remember it. Very important in real life when you're baking a cake. The amount of sugar to the amount of flour makes a difference. It's a relationship, and that is what a ratio is. It's a relationship between two or more things. There are many methods you can use. If you don't like my methods and you have a different method that works well, feel free, no one minds, just as long as you have something that works. There's a few different types of questions, and all you're doing is thinking of scale factor, comparing amounts, and making use of that. So the first one is simplifying the ratio. So they ask you to write the ratio in simplest form, and we've got 500 grams of flour and 0.7 kilograms of sugar. Now, ratios in simplest form have no units, and they are integers. So that's pretty much the only requirement. A ratio is a comparison of two of the same things. So if we've got 500 grams of flour, then that is I'm going to just make them both 500 grams, and I'll make this one into grams as well, so that's 700 grams. So get the units to be identical first, and then obviously divide or multiply by the same number to get the same ratio. So as long as you divide or you multiply by the same number, you have got the same ratio every single time. So a ratio of 1 to 2, obviously that's the same as 3 to 6. And if we times by 10, 10 to 20. And if we times by, if we divide it by 2 or times by a half, be a half to 1. And all of that is the same ratio. As long as you multiply or divide, you have the same ratio. The only one of those is simplest form, and that's this one here. So they must be integers, both numbers, and no fractions, no units. If they ask for simplest form, get it into simplest form. If you have one of those area volume ratios, if you work in simplest form, it's much easier than working with the numbers they give you, so please try and do that. Okay, so here's another example. So this one is clearly not simplest form because there's some fractions. And so you're going to multiply out by the lowest common denominator, which is 4 and 4 and 4, as long as we're multiplying by the same number. So that's 2, that's 24, and that's 3. And that's the ratio in simplest form. Okay, multiply or divide by the same number consistently. Second type, one amount is given. So we have 70 boys, and the ratio of boys to girls is 14 to 5. Do label it so that they can see that you actually know who's who, and you can get all your marks. So hopefully you know that 14 times 5 is 70. So we're going to multiply this side by 5 as well and get 25. Now, if you can't see the ratio straight away, it's actually super easy. Your ratio is always, the scale factor is always these two numbers on top of each other. So either 14 over 70, which is 1/5, or 70 over 14, which is 5. So you have to be multiplying by one of those numbers. And if you're going to go from the small one to the big one, obviously it's going to be 70 over 14 that you're multiplying by. So if you don't know your tables, you just say 70 over 14, multiply by that. The ratio also works this way and this way, so you can go sideways. So if I say 14 times by, and my two numbers are 14 over 5, if I multiply it by 5 over 14, I'm going to get 5. So in other words, I can make a ratio going from 14 to 5 or from 70 to 25. So I can go 70 over 25 or 25 over 70. And if I go this direction, right, then I will multiply by one of those two and I'll get the same answer. So you could have multiplied by 25 over 70. Again, you want the smaller one. So you're going to multiply by 25 over 70. My pen's being a bit difficult. Here they've got if the ratio of blue to green paint is 3 to 10, same type of question. They've told you that there's 17 liters of blue paint and they're asking for the amount of green. So 3 and 17, you can't see the scale factor straight away. It's either 17 over 3 or 3 over 17 for absolute certain. Just take a pair and use those. Now I wanted to get bigger, so I'm going to multiply by 17 over 3. I'll get 10 times 17 is 170 over 3, and then I can simplify that and get 56 2/3 of a litre, which makes sense in a real life question. But if you left your answer as 170/3, it would be fine as well. I could have equally said, well, to go this way, I must be multiplying by either 3/10 or by 10/3. And since I wanted to get bigger, I'd go 17 times by 10/3. And not too surprisingly, I'm back where I was. So basically, you can use any pair, a horizontal pair, a vertical pair, and that's your scale factor. And you can multiply by it. And obviously, if you wanted to get bigger, you multiply by the big version. And if you wanted to get smaller, you multiply by the small version. So hopefully that's nice and straightforward. In terms of scale on a map, it's always linear. So we're always talking centimeters, meters, millimeters, never kilometers squared, meters squared, centimeters squared, right? Never. And the units are the same. So if they say to you, the lake is 5 centimeters, how big is it on the map? Then you'd put centimeters here and centimeters here, right? And obviously you multiply by 5, and we can multiply this one by 5, 1, 2, 3, 4, and that's how big the lake is in reality, right? If it's 1 to 50,000 times. Centimeters to centimeters, nothing has changed. And that would be the length of our lake, right? Obviously, you might want to change this to meters or kilometers. So you might divide by 100 and say 2,500 meters long. And you might want to turn that into 2.5 kilometers even, right? But the actual initial units are the same. If for some reason you wanted to work it out in terms of kilometers from the beginning, it would be 1 centimeter. Well, let's make it millimeters because that will be easier to convert to kilometers. Or meters even, 1 meter to 50,000 meters, right? You just make the units the same. And so if I want to make it into kilometers, I'm going to divide this one by 1,000. So it's 1 meter is the same as 50 kilometers. And that's fine as well. But your original ratio is the same units. And of course, if you want to have things squared, if you want to have the area of a lake, then you're going to use the square of the ratio. So if I want to know what the area of the lake is, and they give it to me, they tell me the area of the lake is 2 square meters, I'm going to have to use an area ratio. And so my area ratio, I'm just going to replace this for now, is going to be 1 to square that, that will be that. So 1 meter squared this is a hell of a big lake, is 2,500 kilometers squared. So our 2 meter squared lake is 5,000 kilometers squared. You must change your ratio so that you're working with an area ratio. So if you have 1 to 50,000 square centimeters, the area ratio is going to be 1 to 25. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Well, 7, 8, right? So that's your area ratio. And that would be, for example, 1 square centimeter to 50,000 square centimeters, right? It would be a good idea, if they're going to change units, it would be a good idea to change them while they're linear, because that's easy. You know how many centimeters there are in a meter, how many millimeters there are in a centimeter. So you change your units while it's still linear. Then you square it, like what I've done here. So there's my changed units, and then I squared it. And now that's my area ratio. And that's probably the easiest way of dealing with this. Third type of question, total amount is given. So they tell you that the amount of money is split in the ratio 2 to 3 to 7 between 3 people. So for every $2 I give this person, I give this other person $3, and I give the last person $7. And then I give them another $2, and I give this one another $3, and I give this one another $7. So basically each time I'm dividing it into 12 parts until it's used up. So this is 12 parts. 2 plus 3 plus 7 is 12 parts. So the first person is getting 2 out of 12 parts of 126. Second person is getting 3 out of 12 parts of 126. And the last person, my pen's not working. I'm going to just plug it in on the side here. Last person is getting 7 out of 12 parts of 126. So you can then go and work this out. And the first person is going to get $21. Second person is going to get $31.5. Now that works out very well for money. If you worked this one out, you would get $73.5. Oh, and you could also subtract to get it, because obviously if I say 126 and I minus the 21 and I minus the 31.5, I'm going to get the last amount. They have to add up to 126. So imagine that this was sheep and not dollars, right? Then obviously the one farmer would have 21 sheep. Then if you round it off, oh my word, this thing is still not working. I think I'll just pause. So hopefully it's going to cooperate now. So the first farmer gets 21 sheep. Then you'd have to give 32 sheep to the second farmer, or 31 sheep, but probably you'd round up because that would be the normal way. You can't give them 30. Well, I suppose you could if they were dead sheep, but if we wanted them to stay alive, it would have to be 32 sheep. That means the last farmer would get 73 sheep, not 73.5. They must add up to 126. So keep thinking and be careful with your rounding off. If you subtract to get your last number, you won't run into an issue with rounding. Last type, increase and decrease in a ratio. If we're going to increase $17 in the ratio 3 to 2, it's just another way of saying make it bigger, right? They could say to you, increase $17 by 50%, and then you'd say, well, 15% of $17 is $8.50, and so if I add that on to $17, I'm going to get $25.50, right? This is just another way of saying increase $17. It means the 17 must be the small bit because you're going to increase it. So you are going to multiply that one by 8.5, and this one by 8.5. Our scale factor is, of course, 17 over 2. And this one will end up at being 11 1/3, right? Sorry, I'm going the wrong direction. I just decreased it. And this one will end up being 25.5. Okay. So if you increase it, then obviously if they give you the ratio the wrong way around, you're supposed to notice. 3 to 2 is not going to give you an increase. 2 to 3 is, you switch the ratio around and you make the 2 is the 17 and the 3 is the new amount. And the relationship between these two numbers is that the one is 2/3 of the other, or the one is 1.5 of each other. So you have increased it in the ratio of 3 to 2. If you're going to decrease it, well, then this is the right way around, 3 to 2. It's going to start off big, going to end up smaller. Again, our ratio over here is going to be 17 over 3, or 3 over 17. We're trying to get the number to get bigger, starting at 2, so we're going to multiply by 17 over 3, and that is the 11 1/3, right? So increasing or decreasing in a ratio, just make sure the ratio is going in the right direction. And it's just like, instead of them saying increase 17 by 50%, they're saying increase it in the ratio 2 to 3, which is the same thing. I hope that's fine.